Wireless standards. In this lesson, we're going to look at wireless standards and how they changed throughout the years, where they were first introduced, and how we use wireless today, and all the changes that were made during those times to lead us to where we are today. At the time of this writing, it's been 23 years since Wi Fi was first introduced to us and made our lives a lot easier by providing us wireless connectivity that transformed the way we used our devices. Whether it was for personal or business use, Wi Fi has become a staple in our technology, and we've come to expect it as a standard way of connecting to the internet and to our networks. Wi Fi has also made its way into the business use cases over the years and is also a staple in organizations of many sizes. Back in 1999, the IEEE, the Institute of Electrical and Electronics Engineers, established the 802.11 standard for wireless communication. Now, devices that were capable of this standard could be used to access the internet wirelessly or networks wirelessly. The standard has been amended numerous times throughout the years, and each increasing and giving us better features in this wireless standard. Each amendment boosted a top speed of the previous connection. And they were also marked by a letter change or sometimes two letter changes that would follow the 802.11. And we're going to look at the series of these amendments and these changes. So again, the wireless standards were managed by the IEEE. And that standards committee was the IEEE 802, and that's hence where the name came from, 802.11 and so forth. Also, to note that the trademark symbol, the Wi Fi trademark symbol, is actually managed by the Wi Fi Alliance. This organization was responsible and oversaw the interoperability testing for devices that would connect to Wi Fi. And if they passed all the criteria and so forth, they would be um, made that they were Wi Fi compatible. So our early standards produced two frequencies that our devices can now connect to, whether it was through the network or to the internet. And that was 2.4 gigahertz, which is the 802.11b, and the 5 gigahertz, which is the 802.11a. 802 and 11b had a theoretical speed of 11 megabits per second, while the 802.11a had speeds up to 54 megabits a second. Even though the 5 gigahertz had a faster speed connection and a faster throughput, it wasn't best when it came to long range coverage. Also, it wasn't the best when it came to penetrating through obstacles in buildings because the lower the frequency, the better the coverage or the long range coverage was, as well as penetration. So the 802.11a introduced in, of course, October of 99, one of the original standards that operated on the 5 gigahertz spectrum. Um, and other frequencies with special licenses as well. And like we mentioned before, the higher, because it was a higher frequency, it didn't have the penetration that the 802.11b did. However, it did have faster theoretical speeds. And the other frequency at that time was in the 2.4 gigahertz was the introduced at the same time was the 802.11b. That was again 2.4 gigahertz, theoretical speed of 11 megabits per second, had a longer range. And also, it was better at penetrating objects and devices and walls and so forth. One of the drawbacks to 802.11b was it's prone for interference because other devices use that frequency, microwaves, cameras, baby monitors. It was prone to interference with those devices. So even though it was popular for the wireless connectivity spectrum, it was also popular for those other devices. So therefore, it was more prone to use it was more prone for it to be interfered with those other devices. One of the first major upgrades came in the year of 2003. During that time frame, the 802.11g products emerged on the market after the ratification of the 802.11g frequency. This was an upgrade to resolve the flaws in both 802.11a and B frequencies. 802.11g attempted to combine the best of both worlds of 802.11a and 802.11b. The 802.11g supported bandwidth up to 54 megabits a second, and it also used the 2.4 frequency range for greater range. 802.11g is backward compatible to 802.11b, meaning that those products that they were 802.11b would work with the new 802.11g access points in wireless devices. Now, the pros to the 802.11g, it's supported by essentially all wireless devices and network equipment that was in use at that time. And the cons was the entire, when you connected to an 802.11b, the entire network slowed down to match the speed of those devices. So that was one drawback to the 802.11g. Now, the next modification or upgrade came with the introduction of the 802.11n in 2009. 802.11n, or sometimes known as wireless N, was to improve the 802.11g in the amount of bandwidth that it supported by using several wireless signals and antennas called MIMO, multiple in, multiple out. Um, Industry standards groups ratified the 802.11n in 2009 with specifications providing up to 600 megabits of network bandwidth. 802.11n also offered of a somewhat better range rather over the earlier Wi-Fi standards due to its increasing signal intensity. It was backward compatible to 802.11a, b, and g. Now, the good thing about the MIMO, the pros, was significant bandwidth improvement over the previous standards. It had a wide support for a lot of network devices that was out there. On the con side, it was more expensive to implement than 802.11g, and it had multiple signals that may interfere with other 802.11b and G based networks that was close by. But again, with the new architecture, the MIMO, it introduced that multiple input, multiple output, and it had an overall better throughput in the wireless. So this is one of the biggest jumps in bandwidth that we've seen with the upgrades. Our next upgrade came in the year of 2014, and that was with the 802.11ac. And we also seen a new name or different name that began to be marketed or targeted, and that was the Wi-Fi 5. Even though these names were used in previous years, this was one of the first times that Wi-Fi 5 was actually publicized and used on products and marketing and so forth. So the generation of Wi-Fi that signaled a popular use was the 802.11ac. Uses the dual band wireless technology, and it supported simultaneous connections on both 2.4 and 5 gigahertz devices. So, and also offered backward compatibility to A, B, and G and N. And the bandwidth was rated up to 1,300 megabits a second on the 5 gigahertz band and up to 450 on the 2.4 gigahertz. So most home wireless routers were compliant with this standard. So it worked right out of the box. Now, 802.11ac is more expensive to implement, and performance improvements were noticeable in high bandwidth applications, gamers, and things along those lines. It was really noticeable. Now, couple other features about the 802.11 AC is the signal modulation. It was faster data speeds because it had 8 MU-MIMO streams. That was twice as many as in the Wi and the MIMO. So it was like nearly 7 gigabits of throughput. So this was a significant increase even in the previous standard. That was Wi-Fi 5. Wi-Fi 6 came along in February of 2021, and Wi-Fi 6 had even more significant improvements in the area of speed as well as in the technology. So, with Wi-Fi 6, the 802.11ax, it operates on the 5 gigahertz and the 2.4 gigahertz channels. And however, the channel widths were 20, 40, 80, and 160 channel widths. So we were talking about 1,000, about 1,200 megabits per channel. It offered 8 bidirectional MU-MIMO streams, of course, the wider channels, and also had a unique feature. Previously in wireless, cellular wireless, there was a technology used that this new Wi Fi 6 adapted. And that was the orthogonal frequency division multiple access, OFDMA. So it was based on a cellular technology. And what this technology is basically in groups or settings where there are a lot of wireless users, say, for instance, in a stadium or in a big recreational area, it allowed for more users to be able to use those additional streams. So therefore, it offered the higher speeds and also had more density with it, allowing a lot more users to be on it and to be able to support those users. So we had a tremendous increase in supporting large groups of people, of users. Also, we had higher speeds as well. So this is the 802.11ax or Wi-Fi 6 as it came about. So here we have a summary of our wireless standards. As you can see, we looked at the 802.11a and the frequencies that 802.11a was the 5 gigahertz frequency. Maximum theoretical throughput was 54 megabits. 802.11b was the 2.4 frequency. 11 megabits is theoretical throughput. 802.11g, 2.4. It was 54 megabits as far as throughput, theoretical speeds. 802.11n was the 5 gigahertz and the 2.4 gigahertz. Maximum MIMO streams was 4 MIMO antennas or MIMO streams, 150 megabits throughput. But maximum theoretical throughput was a total of 600 megabits. 802.11ac, 5 gigahertz. Maximum MIMO streams was 8 times MU-MIMO. And there was a maximum theoretical throughput of 866.7 megabits and a maximum theoretical throughput of 6.8 gigabits. And finally, we had the 802AX. That was 5 gigahertz and 2.4 frequencies. Had 8 times DL and UL MU MIMO streams. 1,201 megabits was the maximum theoretical throughput, and the maximum throughput total was 9.6 gigabits, or almost 10 gigabits. So that again, the summary of our wireless standards. Sometimes in Wi-Fi and organizations, and sometimes in home cases, you found yourself needing to extend your wireless coverage to other buildings. Sometimes these other buildings may have been on the same property or same area, or sometimes across the towns, many miles away. In order to do this, you would have to set up a long range fixed wireless. And or long range fixed wireless was a setup of a point to point antenna system that would connect your wireless from one location to another location. And users at that far location would be able to access your secured wireless that you had at the first location. This could be accomplished in frequencies of 2.4 or 5 gigahertz. You would have to survey the area for the best option to make sure there's no obstacles, or if there was no obstacles, what would be the best frequency? As we mentioned earlier, sometimes there can be competing frequencies, and instead of using 2.4, you may want to use 5 gigahertz or vice versa, depending on the area that you're in. What would be the best option? Some frequencies may require a license. You would have to check with um, your local entity to make sure that you have a secure license for other frequencies outside of the 2.4 or 5 gigahertz. Sometimes there's also signal strength limitations, meaning you could use one frequency, but your radios can only power up to a certain limitation. So you'd have to check the regulations or check with your provider to see which one of those would fall into your situation. Radio frequency identification, or RFID, is used in a lot of applications. We use it for asset tracking or tracking or tagging the devices or tagging sometimes even animals with a radio frequency identification. So those assets can be tracked. RFID has three main components: a scanning antenna, a transceiver, and a responder. And it worked on the radar technology. So basically, how it worked is the radio was transmitted to the tag, and the RF power powers up that tag, and it communicates or transmits the ID information back. It was a bidirectional communication, meaning you sent the signal to the tag and it returned information. So it was bidirectional. And there are two types of tags with the RFID. That was active or passive. With active, those tags on that asset or that device has its own power source there. Whereas passive, it did not have a power source. Near field communications or NFC is based on the RFID technology, so it's similar, very close. However, the transmission range for NFC was very, very short, basically in centimeters. That was the distance between that you could use the NFC type of technology. Also, is bidirectional capability, and it works actually along with Bluetooth. It was built into a lot of our phones. Also used as identity access token, gateway payments, payment swipe with phone. That is the NFC based on the RFID technology. Okay, let's summarize all the technologies and the areas that we covered in this lesson. We talked about the wireless frequencies, 2.4 gigahertz and the 5 gigahertz, and the standards that brought them to where we were. We talked about the long range fixed wireless, NFC, and RFID. Okay, that is it for this lesson. I will see you in the next lesson.